All right, we're back. We are in note 3 of Calc AB. We are on page 4, and this is kind of like the second problem. So let's see if we can do it. The graph of a particle's position over time is, so position over time. This is actually really weird. You are seldom given position over time. So it's particle's position over time. Interesting. Usually you're given velocity. In general, the first derivative graph is like the most common by miles. Anyway, position over time. Good to know. Use it to answer the questions. State all times. Use it to answer the questions. A. State all times when the particle is not moving. All right. So this is position over time, right? Not velocity. So we're not looking for the zeros of this. We're looking for when position doesn't change. So when is position not changing? When you're just sitting here at -1, right? Your position is -1. So it looks like the function is named x of t in the next part. So x is just equal to -1 the entire time between 6 and 8. So I'm going to say the particle is not moving. Notice the sentences. People object to that, but people need to get over it. The particle is not moving. Not moving from t equals 6 to t equals 9. I don't know. Well, first of all, it's 8, so I don't know why I keep saying from 6 to 9. From 6 to 8. I mean, a more normal way of writing that. I don't know why I wrote that way. That way. So you'd probably more likely see 6 to 8. That's how I would prefer to have written it. I don't know why I wrote it that way. Because its position is constant. So if its position is constant on that interval, what does it mean about its velocity? If its position is constant, its velocity must be equal to 0, and that means you're not moving. So v of t is equal to 0. All right, I think that thoroughly answers that. Write a piecewise defined function. Write piecewise defined functions for each of x of t, v of t, a of t. Okay, I think we can do that. So x of t is going to be the most annoying, really, because we're going to have to write. Well, they're not bad. The slopes are easy enough. I think we got this. All right, let's do x of t first. So how many branches are we going to need? 1, 2, 3, 4, 5 branches. Holy cow! All right, here we go. So x of t. I don't think I'm going to fit all 5 there, but x of t is, all right, the first branch. I'm going to say that I know it goes through, it has a y-intercept of -2, so I might as well just use that. Still going to do point slope, though. I'm going to say that this point is 0, -2, and then the slope is you go up. What is the slope? You go up 4 and over 3, 4/3. So I'm going to say it's -2 plus 4/3 the quantity t minus 0, and that's valid between 0 and I'm going to go all the way to 3 on that one. Just hit it the first time it shows up, right? So if I plug 3 in there, I get +2. So I'm allowed to include 3. So for the next one, I'm going to start at the point 3, 2. So I'm going to use that for my point sloping. 3, 2. The slope is down 2 over 2, so -1. So I'm going to say it's 2 minus the quantity t minus 3, and that's valid. We're to use 3 once, so we're not going to use it again. And we'll go to 6. From 6 to 8, we know that the position is -1, so it's just going to sit there at -1. We already used 6, and we'll use 8 this time. From 8 to 9, the slope is 3 because you're going up 3 and over 1. So the slope is 3. I'm going to use the point 8, -1, so it'll be -1 plus the slope is 3, t minus 8, and that's valid between 8 and 9. And then between 9 and 11, the slope is -2. I'm going to use the point 9, 2. So 2, slope is -2, t minus 9, and then that's valid between 9 and 11. All right, I think that is x of t. So now I need to find v of t. I can do this two ways. I could just look at my function for x of t and find the derivative of each and every branch, which is actually, I think, what I'm going to do. Or I could go back to the graph and just look at the slopes of the line segments. So here, v of t is going to be, now the issue, there's a lot of places where the derivative doesn't exist for this thing. So those places, let's highlight them in this color. Here, the derivative doesn't exist. Here, the derivative doesn't exist. Here, and here. So what are those values? Well, if you look at our definition of x of t, they're actually the breaking points. And it's really common for a piecewise function to not be differentiable at the breaking points of the branches. So, or the transition point, I don't really know what they're called. I think breaking point, I always call them the break points. All right, so what are we gonna get? We're gonna get 4/3, but when is that valid? So it's actually valid at 0 if you want to include it. Is it? I'm gonna not include it. I'm not gonna worry about that. Like, does the derivative exist at 0? I don't think so. So I'm not gonna include it. So 0 to 3. So not differentiable at 3, right? That's a sharp turn. Not differentiable, don't include it. Then the slope becomes -1, and that's valid between 3 and 6. Not differentiable at 6, don't include it. When you have a horizontal line, the slope is 0, so it makes sense that we're going to say 0 here between 6 and 8. And then the next one's going to be 3, and that's between 8 and 9. And then the next one is going to be -2 between 9 and 11. So you can either get those by taking the derivatives, right? So you can just look through and say, like, this is the v of t. So you can find it there. Double highlighter, hate it. There. There's like no slope there. And then there, right? Those are the values that we got. Now, the acceleration. Well, if the velocity on each interval is constant, the derivative of a constant is 0, which means the acceleration is basically 0. But if the velocity doesn't exist at a point, the acceleration can't exist at that point. So this is a weird version of 0. So a of t is going to be equal to 0, but it's a piecewise function. So it's 0 between 0 and 3, and then it's 0 between 3 and 6. Ooh, what are you? How do I get rid of you? Okay, between 3 and 6, and then it's 0 between 6 and 8. Is there a better way to write this? Probably. Is this right? Yes. And that's how I, when I have to make a choice, I choose to do the right thing. 9 and 11. So you could probably get away with saying a of t equals 0 for t an element of 0 to 11, comma, t not equal to 3, 6, 8, 9. You could do that. 11, I guess, and 0. So I don't know. I'm going to write it this way. I think this makes most sense. All right, so these are our piecewise functions. I would try to graph them on the calculator, except like no one in their right mind wants to put in something with that many branches, so I'm just not going to do that. I think we answered everything, so I'm going to stop the video here and come back in the next video and keep going. So hopefully I see you there.